Hello children, this is Ashwati Krishnan. I am back again with another interesting topic today. So today we are going to start module 4. So before watching this video, make sure you are thorough with the previous modules for a better understanding of today's topic. So get ready with your pen and book. So today we are going to discuss the important terms related to spherical mirrors. Now, can you tell me what type of mirror is shown in the diagram? Very good. It is a concave mirror. So the terms that I am going to discuss today is applicable to convex mirror also. Okay, because both are spherical mirrors. So I'm starting with concave mirror. So concave mirror, it is a part of a sphere. I have told you, as the name suggests, spherical mirrors, it is a part of a sphere. So this is how it looks like. Okay, it is a part of a sphere. This dotted line shows the sphere. And we all know that a sphere has a center. That center is called center of curvature, and it is denoted by C, letter C. So remember, the center of the sphere, of which this mirror is a part, is called center of curvature. So the definition says the center of curvature is the center of the sphere of which a curved mirror a part. These definitions are very important. So please be thorough with the definitions. Now let's move on. Next point, see here you can see the black point on the mirror. That is called pole of the mirror. Okay, it is the midpoint of the mirror. So don't get confused with center of curvature and pole of the mirror. Okay, the center of curvature is the center of the sphere. It is the center of the sphere. But pole is the center of the mirror. Okay, or center of the reflecting surface. This is the center of the sphere and this is the center of the mirror. Now let's move on. Yes, this dotted line. What does this dotted line indicates? This dotted line indicates the principal axis. Okay. So since it is imaginary, it is denoted by dotted line. So I have told you in the previous module that all imaginary lines should be dotted. So this principal axis is an imaginary line passing through the center of curvature and the pole. See, from the diagram itself it is very clear. C is here, P is here. So this imaginary line is passing through C and P. Now next is radius of curvature. So from the name itself you will get radius. So you have a sphere, it has a radius. It is denoted by capital R. So what is radius of curvature? It is the radius of the sphere of which a curved mirror is a part. See, here in the diagram it is clear. This is the radius of the sphere and mirror is also a part of this sphere. This is one definition of radius of curvature. Another definition is, yes, it is the distance between center of curvature and the pole of the mirror. Okay, so you can learn any one of this definition. Okay, so distance between center, this from here to here, this distance is what we call as the radius. Okay, so I think the second definition is easy compared to the first one. And don't get confused with the principal axis definition and this definition. Okay, this is a line, yes, which passes through, the full line which passes through. Okay, but for radius we take it from center to pole. So don't get confused between both. Now next one is very important point, that is focus. Okay, so here you can see parallel lines here. So you can see parallel lines here. Yes, these parallel lines, when they hit the mirror, it gets reflected. Okay, the rays will reflect and they will meet at one point on the principal axis. So why we are using parallel rays? So here one point that you should remember here is to get the focus of the mirror. Okay, so to get the focus of the mirror, we use distant object method. Distant object method. Okay, distant object means the object which is very far. So far objects are usually considered as infinity object or infinite objects. So the object will be very far and the lights coming from the far objects are nearly parallel. So if rays are parallel, then only it will meet at a common point called focus. So why are we taking distant object? So it is considered that parallel rays are formed from distant objects. So if we choose a distant objects, the light rays are nearly parallel. So only if the rays are parallel, then only it will converge at focus. Now see the definition. It is the point on the principal axis. See, this is the principal axis. I told you it should be dotted line. Okay, since it is a diagram which I have copied, it shows like this. So it should be dotted line. But when we draw the diagram, we usually take it as solid line just to avoid the confusion. Okay. So now see the definition. It is the point on this axis where parallel rays, these are the parallel rays, they meet after reflection. Okay, meet or converge after reflection. This is for concave mirror. Okay, concave mirror. This definition is applicable only for concave mirror because we are using the term meet and converge. Okay, so only concave mirror will converge the light rays. It is a converging mirror. Converging mirror. Now what is this point called? Yes, I have discussed this point is the pole. Now what is the distance between the focus and the pole called? So we know that from center to pole, it is the radius. Now focus to pole is called exactly focal length. So now what is the definition? It is the distance between the principal focus and the pole. See, from the diagram itself it is clear, from focus to pole. So it is the distance between these two. This is the focal length. So don't get confused between radius of curvature and focal length. Radius of the curvature is from center of the sphere to the pole, and focal length is the from focus to the pole. Now next important term is aperture. So aperture is nothing but it is the part of the mirror which is exposed to incident light rays. So this might confuse you, like this is the reflecting part, right? When we hold the mirror, we see ourselves in the mirror. That is the reflecting part of the mirror. So this part which is exposed to light, so light comes and hits that part, that is called aperture. Or another definition is it is the effective diameter of the reflecting surface. So this is the part I have shown the mirror in the previous slide, not in the previous slide, I mean the previous module. So you have seen real image and virtual image in two different types of the mirror. So this part is the reflecting side of the mirror. Okay, So this effective diameter of this mirror is what we call as the aperture. It is the mirror, okay? When you hold, like when you draw diagrammatically, this is how it looks like. And when you extend this, you will get a sphere. It is not the diameter of the sphere, it is the effective diameter of the reflecting surface. Don't get confused between both. Now let's see the relation between R and F. So here I have told you that R is from radius, R is means radius of curvature from center to the pole, and focus is between C and P. It is the midpoint of C and P. So now what will be the relation between F and R? R equal to 2F. Yes, in the diagram you can see this is your R, this is your F. So this focus is midpoint between C and P. So R will be 2 times the focal length. This relation you should remember. This is important. Now just remember rough. Okay, this is a shortcut way to remember this relation. Rough. We use rough book or rough surface. Rough. Okay, while you pronounce, that will help you to understand better. Okay, R equal to 2F. So this is applicable for all mirrors. Okay, not only for concave. Yes, now I have told you in the beginning, whatever terms that we are discussing today is applicable to convex mirror also. But what is the difference here? So we have a center of curvature. See, this is your convex mirror. Okay, so we have radius of curvature, we have center of curvature, we have pole. Okay, and we will have, yes, I will discuss you about focus and focal length little later. But what is the difference between this and this here? So for concave mirror, center of curvature is in front of the reflecting surface. So this is your reflecting surface. This blue shows the reflecting surface. So center of curvature is in front of the reflecting surface. That means in front of the mirror. Now what about convex? The line shows the back side of the mirror. So center of curvature of convex mirror is behind the mirror. Behind the mirror. So C is behind the mirror. Now what about radius of curvature? Yes, here radius of curvature is, radius of curvature is in front of the mirror. Now what about this? Radius of curvature is behind the mirror. Okay, this is the only difference between these two. Rest all definitions, everything is same. Okay, now about focus and focal length. See, this is the diagram for convex mirror. So I have told you for concave mirror, let's move back. Yes, for concave mirror, it is a converging mirror. So what happens to the light rays when it hits the mirror? It will converge at a point in front of the mirror. Now what about convex? Yes, convex mirror is a diverging mirror. So what happens to the light rays when it hits the reflecting surface? Yes, this is the reflected ray. These are the reflected rays. It will diverge. Now this, when you extend this light rays, you can see that they appear to diverge from a common point. That common point is called focus. Understood? The parallel rays, after reflection, they appear to diverge from a common point. So for convex mirror, focus is behind the mirror. Since it is formed behind the mirror, the focus of convex is called virtual focus. Now what about concave mirror? In case of concave mirror, the focus is formed in front of the mirror. So it is called real focus. That is the only differences between concave mirror and convex mirror. Focus and focal length. What about focal length? See, this is the focal length. Now focal length is denoted by small letter f. The definition is same. It is the distance between pole and the focus. But where is it formed? Behind the mirror. That is the only change. Otherwise the definition remains the same for focal length. But for focus, we have seen the definition of principal focus. What is the definition of focus for concave mirror? It is the point on the principal axis where parallel rays of light meet or converge after reflection, because they actually meet. But for convex, they appear to diverge from a point. Here also the point is on the principal axis. So it is the point on the principal axis where parallel rays of light appear to diverge after reflection. Okay, since they appear to diverge, we call the focus as virtual focus. And since it is formed on the principal axis, this focus is also called principal focus, because the focus is formed on the principal axis. Okay, so we have discussed the important terms. Related to mirrors. So what are the important terms? Just try to recall what we have learned so far. Yes, we have discussed the center of curvature. Yes, center of curvature, C and C. For concave mirror, it is in front of the mirror. For convex mirror, it is behind the mirror. Then second point is pole of the mirror. It is the midpoint of the reflecting surface or midpoint of the mirror. Definition is same for both. Now radius of curvature, it is the distance between center of curvature and the pole. Definition is same for convex also, but here for concave, radius of curvature is formed in front of the mirror, and for convex it is formed behind the mirror. That is the only difference. Okay, then principal focus. For concave mirror, principal focus is in front of the mirror, so it is called real focus. And for convex mirror, principal focus is behind the mirror, so it is called virtual focus. So these are the important points that you should remember when you learn about the important terms related to spherical mirrors. So that's it for today. Have a good day. Thank you.